Good afternoon. Hello, can you hear me?
Hello, good afternoon, madam. Your voice is a bit far.
Good afternoon. We can hear you clearly.
Is it better now?
I think it's better. You're welcome.
Yes, please, it's better
Thank
now.
you. Okay, please pardon me. I have cold, and so I don't know if that's why my voice is down. But I'm going to try as much as possible to kind of shout so that you hear me better. I hope we are doing well though.
Yes, madam. Yeah, we just miss you a little bit.
Yeah,
Who's
that's a
HR?
serious lie. It's me, man. That's a
Oh, sorry,
serious
madam.
lie. That's a serious lie.
Madam, why
Students
are we
never
so?
like their teachers or whoever is teaching them. Anyways, last week you had a free time to read by yourselves. So what did you learn? What did you read about? We were supposed to do user interface design. Yes. It was a reading assignment. I hope you know though.
Yes,
Yes,
please.
madam.
Or you took the day off as holiday. Yes, can someone tell us what's they read on? Like what's they studied or learned last week with regards to user interface design?
Hello, madam.
Yes, sir.
Yeah, so I want to say something about the user interface design.
Okay.
I read that maybe user interface design is how users interact with computer system and how they,
Oh, okay.
yes, basically how they interact with computer system, the interfaces, the menus, and other connected components. So I further look at some principle that is used to, design a user interface, which
Mm,
I then look at them, you being able to think like a user. Then also looking
okay.
at anticipating the future needs of the user. Then
Oh, okay.
providing flexibility. And finally, manage data effectiveness. So this is the little that I can say about the data user interface.
Thank you very much, Justice. Any other? Any other? Yes. Or should I start mentioning names? I hope you know I have a record of all those who have been talking in class.
And
So, madam, I
madam.
also I also had personal studies, and then I looked at the definition of the user interface, where it is the system that helps the user to interact with the system, the computer system, or the system of an information, the system of an organization. For example, the ATM system, where the user has the chance to interact with the machine, input these particulars and all that. And then I also looked at the 7 habits of a successful interface designer, where the person must
Okay.
understand the business, the person must think like or behave like, the person must think like he's part of the users of whatever system
The
he or she
system.
is in, the system. And I also
Okay.
went ahead to look at the human computer interface.
Interactions and interfaces.
Interactions,
Okay.
interactions, yeah. So that was where I was able to read up to.
I thank you very much.
Yeah.
So, because you're IT students, you'll be studying human computer interaction, where you learn about ergonomic features when it comes to user interface designs and then things users use, even including posture, like the postures of sitting, the right postures of sitting, and all of that. So, whenever you want to develop or create a new computer interface for people to use, there are things you have to consider. So, you'll be treating that as a course moving forward. It's called HCI, Human Computer Interaction. But thank you very much. I think you've all done well. So when you get there, you learn more about it. Today we are looking at data design. Are you doing database management this semester, or did you do it last semester?
No, please, we
No,
have not done
please.
it.
You've not done that yet.
Yes, please.
Okay. Not yet. So you'll be doing database management. Let me see if I'm taking database. No. Okay, I'll be taking data warehousing. So you'll be doing database management, and this data design would help you understand the concept of database more and appreciate it the more. So I'm not going to go so deeply into it, but I would help you as much as possible so you understand the basics, in that when you approach your database course or program, it wouldn't be so difficult or far-fetched for you. And for the most part, you have access to your reading materials. So you can also try and then read more on them. And then in case you have any questions, you bring them up so that we discuss during class. Is that okay? Can someone pray for us? So we continue.
Shall we pray?
Yes, sir.
Great one who that could not hold you captive, the only one who in the gave you a Lord. We adore your name. We lift your holy name up and we exalt your name. It is just by your grace that is why we are part of the living. And so we want to say glory be to your majestic name. As descendants of Adam and Eve, we have sinned against thee, and so we confess our shortcomings, our sins, and our evil acts before thee. And then we pray that with the blood of Jesus, cleanse us. We are about to commence today's lectures. Pray for the wisdom and understanding granted King Solomon, so that when we have successfully completed the lectures, we shall come together to say glory be to your name. These are many we ask in the name of the Father, the Son, and the Holy Spirit. Amen.
Amen.
Amen. Amen. This is a
Amen.
bishoptic prayer. Amen. Anyways, so today we'll be looking at the basic data design concepts. Please, I want to be sure you can hear me as much as possible. I hope you can hear me clearly.
Yes, madam, you can.
Okay. All right. So we'll be explaining some data design concepts. We'll be looking at data structures. Have you done that already? Algorithms and data structures.
No, please.
Okay. So I'm sure.
Yes.
Okay. Database
Yes.
management.
Yes, we've done it.
You've done algorithms and data structures,
Yes.
where you looked at various
No, 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 no,
algorithms,
no.
sorting.
No, no.
That was the basics.
Hey, basics. Which one is basics?
We did introduction to programming. It just introduced it to us, but we didn't go deeper.
Deeper. Oh, okay. I'm trying to say it's also a course on its own that you would be doing. Algorithms and data structures. Is this your first semester, level 200?
Yes, please.
Yes,
Oh,
please.
okay. So hopefully second semester you should be doing database, data structures, and all of that. That also means that you should up your C++ game. Okay. Go and improve on your coding in case you haven't done that. Please do that. Anyways, that's just by the way. So we'll be looking at just the basic concepts so that we will not digress from what we are supposed to do. Okay. So we'll also explain the main components of a database management system and why at all are system analysts looking at database management systems and all these concepts. Okay. So basically, that's what we'll be looking at today. And I'm sure we all use one app or the other on a daily. You use WhatsApp, Instagram, TikTok, and all of that, right? So imagine MTN or your bank stored all your data in any file at all, any random file with no structure. What do you think would happen?
Bye-bye.
Or when they were registering the Ghana card thing, then before you know it, your all your information is out there. You wherever you find, you try searching for anything, you come across your details, all the details you provided about yourself. What do you think would happen if that becomes a thing that is actually existing? What do you think will happen?
It will be difficult to get your data, like when they are searching for your file.
Okay.
For me, I
Yes.
think there will
Your
be a script.
information
Yeah,
will
you'll
be
be at risk.
Please, 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 please. I beg you, one after the other. Okay, so let's organize ourselves properly. Good. Mark Sam. Mark Sam.
hear me.
Hello, Mark
Yeah,
Sam.
when I can hear me.
Yes, I can hear you now.
Yeah, madam, there will be data insecurity.
Data insecurity. Okay. Any other? Any other, please? Naya, your mic is on.
Yes, please. Can I say it will fall under cyber threat?
Good. So it's almost like what Maxam said. There's some sort of insecurity, so definitely there could be threats. Yes. Any other? Look at what's been happening with Momo these days. Any random person can just call you. My son is got two phones, so my mistake or something, something, or they'll just send you a message and all of that. What do you think would happen if MTN decides to store your data in some random file somewhere and all? Emmanuel Badger, your hand is up.
Yes, madam. Yeah, you could easily be targeted by fraudsters and like criminals. So basically, you'll be at risk of financial fraud or whatever harm they can use like those details for.
I see. That's true. So that's why data design matters. That's why we are studying what we are studying. So when you look at data design carefully, it's all about how we organize and how we are supposed to store and manage our data properly, okay? And also work at it accurately. So as system analysts, your duty is not just to build systems or design it. You also have to know how the data flows and how it is what's stored so that information or data does not, fall in the wrong hands and probably cause the whole system to fail because you didn't design, that data flow properly. Okay. So imagine GCT, you log into your SIP to check your student results, and then somebody else's result is showing on your SIP. Or what do you think will happen? You don't make any transaction, and then there are deductions coming from your accounts, wrong amounts coming in and out. So you have to know how to structure your system properly to avoid these things. So before we even talk about databases, how do you personally organize your files on your laptop or phone? How do you do that? Can anybody share with us?
Hello, madam.
Rafik.
So I group them into folders. Let's say if I have music, I can group all of them into music folder. If I have tests or Word documents, I can also group all of them into. So I group similar files into one folder.
Oh, okay. That's cool. Do we have any other? Justice.
Yeah, hello, madam. Yeah,
Yes.
so to add up to what my brother just said, you basically group them into folders. But for me, I just take the parent folder. Let's say, for instance, this course that we are doing, and this program that we are doing, IT, that will be the parent
Yeah.
folder. Then under the IT, we have the level 100 and the level 200 folder, which is a subfolder. Then within the level 100 and level 200, you may have another subfolders inside, which is the semester 1 and
Okay.
semester 2. Then within the semester
Oh,
1 and
okay.
semester 2, you have the courses folders that you have or you are doing for that particular semester. So that's how sometimes I organize my folders.
Realize it. Good. So what we are doing is what we call structuring data, okay? And systems do the same thing, but in a more formal way. So in short, it's how data is arranged inside the system. That is what data structure is all about. It's a framework for organizing, storing, and then managing data. And they consist of files or tables that interact in various ways. In most systems, people store their data in the form of spreadsheets, like Excel sheets and stuff like that. So each file or table contains data about people, places, things, or events. Okay. So think about it like um organizing a data or a system to store data for GCTU. There'll definitely be a table for students, okay? Because we are saying that they consist of files or tables that interact in various ways. So if GCTU is one of the tables, within GCTU, we have a table for courses, we have a table for students, we have a table for lectures, we have a table for, all these things. And they are relatable things, so they have to interact in various ways. Okay, so for instance, your student ID connects you to your courses. So if there's a student ID as a broad table, beneath that table, which is like a broad folder, the sub of that folder would be probably your courses, your results, the payments you have made, the details about you, the students, and all of that. So that's how data structure works. And why does this really matter? So that you would avoid things like duplication, you avoid things like errors. And when there's duplication, there's redundancy. So it affects the system. It makes the system become what's slow. And you might end up making wrong decisions. Okay. So let me tell you a short story about two auto shops in this particular slide. Now, the two auto shops are Mario's shop and then Danike's shop. When you read your first book or the reading material that was provided for you, you would see this illustration in there. So let me just summarize it. Mario owns a mechanic shop, okay, and he uses two separate systems. One system stores mechanics detail, and then another system stores jobs done on the cars. Now, here's the problem. Whenever a mechanic works on a car, Mario has to enter the mechanics detail again in the job system. So at the end of the day, chances are data is entered twice. Okay. Because whenever somebody works or does a job as a mechanic, the system will, like somebody must now go back and then record it. What if another mechanic had already recorded a job same person did, previously? So the data is entered twice and mistakes happens and things like that. So at the end of the day, there's basically data redundancy. But then when it comes to Danica also runs a similar shop, but smarter, okay? She uses what? A database system where everything is connected. So she stores mechanic details once in just a table. Then when recording a job, she just uses the mechanic's ID or number to link to that mechanic. So instead of maybe rewriting Kwame, senior mechanic, he has done this job and that job, he just enters Kwame's ID, and then whatever we have on Kwame comes up, and he just enters the job Kwame has done. What happens with this? There will be no repetition. There will be fewer errors. So imagine today Kwame did a job, and then we write Kwame number 1. Justice does a job, we write Justice number 2. Sechwafia does a job, we write it number 3. Justice does again, we go and write it as number 4. How many times has Justice's name been repeated? Twice. But Danika's system is not like that. All you have to do is to just search for Justice. When his name comes up and then you click on it, every information and everything he's done or the work that he's done, comes up. So it's just a scenario to depict how two different works or two different employees, two different organizations are working with, two different strategies and comparing, how both of them run and which one is better than which. This is what this actually depicts. Okay, so it's just a concept. And this is a representation of that. I wouldn't want us to go into it because I've already explained. All right. So the system, like I said, the system Danica is using is one that connects everything, okay? And it is what we call a database management system. So a database management system is a collection of tools, features, and interfaces that enables users to add, update, manage, access, and analyze data. Okay. So in simple terms, it's the system that controls, the database. And advantages of this database management system is scalability. So in case we have 500 students in GCTU now, chances are in the next 2 to 3 years, we'll no longer have 500. We'll be having over 5,000 students. Can the database, accommodate all these number of students? Yes. That is why it is scalable. Economy of scale, enterprise-wide application, improved security, data independence, data redundancy, data concurrency, data sharing, data integrity, and data sharing. These are all advantages of data based management system. So let's look at security. When it comes to security, what do you think? Why do you think it's an advantage of database management system? Yes, justice.
Yes, madam. So in terms of security, I think since this is an app that's, contains the data for every entries or input that has been entered in the system, you will need authorization before you can access this application.
Patience. Oh, okay.
And in so doing, you have to
Nice.
authenticate yourself to verify that you are the right user who has been given the permission to access the system. So that's how I'll consider it to
Sweet.
be.
That's good. So, for instance, with your system on campus, I mean GCTU, if a lecturer uploads your results and he wants to make changes, he can't just get up and even make changes like that because of the security features in the database. There are processes and procedures he would have to go through, although he's the lecturer who uploaded the results. And that's to ensure that nobody, manipulates results and stuff like that. Do you get? So that's very important. Now we understand that it reduces redundancy. Of course, no unnecessary duplication like that, right? And then when it comes to integrity or data integrity, it ensures that the data stays accurate and consistent. One time you don't come up with this, and then the next time you're searching it and then something else comes up. That's not how it works. Okay. And then when it comes to database management systems, there are so many tools you can use or tools developers can use to create a database management system. I'm sure when you guys start treating database management system, you'll be able to use it, or you will be introduced to these tools so that you can use them to create databases. We have MySQL, we have Oracle, and then the easiest amongst them all, Microsoft Access. So you can download that and then start, or you can install it and then start practicing with it. Okay, all right. Any questions before we proceed? Any questions? Okay. So a database management system has three main parts. We have users and interfaces. Okay, so for users and interfaces, it is how people interact with the system. Okay, so the users run queries, they view data, and then the admin manages the system. And we have other systems too that can also connect with the database. So users work with predefined queries and switchboard commands. The database administrators are also responsible for the management and support of it. And then we have related information system, which I mentioned earlier. Okay. And then a database management system provides support to related information systems that provide input to and require specific data from the database management system. So other people can also access it. Or so for instance, let's use Google as an example. Google is such that it's broad, and because it has database management centers at a lot of areas, including, I think one was bombed recently during the Iraq USA Israel war kind of a thing. I think Amazon's data, one of their database warehouse also got affected. It was in the news. So you can access any system at all can access database. And for those of you who would be moving into data mining and data analysis and stuff like that, whenever you want to conduct analysis or make your predictions and you have your data sets, the data set is stored in a particular system, right? So you can use that system to access or analyze and make your predictions with another database. So that's how it is like. All right. We also have what we call the schema. So the complete definition of a database, including descriptions of all fields, tables, and relationship, is called a schema. Whenever I hear the database schema, think of it as a blueprint, okay, because it defines how the entire database is structured. So if you were the one who designed GCTU system, you'll be previewed to what student entails. For instance, you'll be previewed to student ID, and you know that students, when it comes to students, it has student ID, name, program. When it comes to course, it has course ID, course name. When it comes to results, it has students' results and all of that, you know. So it shows what the table, like it shows the exact tables that exist and how they are connected. It's just like having an architectural drawing to a building. As the architect, you know where everything is supposed to be. So somebody may just be looking at the building or standing in front of the building and may not know what is going on inside. But you, the architect who designed the building, or having the blueprints of the building, which is the schema, know the descriptions for all the fields within that house. That is how a schema is like. And then we have a sub-schema. A sub-schema defines only those portions of the database that a particular system or user needs or is allowed to access. Okay, so it shows only what a specific user is allowed to see. Because we are the users of the whatever, and because we didn't build it, we are previewed to see only our names and courses and grades on the SIP. But those who have access to the blueprints know that behind the name, courses, and grades, there are other things that you can see. Is that okay? Is
Yes, yes,
somebody
madam.
interacting with, sorry?
You were asking if that's okay, and I was like, yes, madam.
Oh, okay. Is somebody else interacting with the slides? Because I see markings on it and I don't know where they are coming from. And I'm not using my pointer. Justice, your hand is up.
Yes, madam. So I want to find out in the user's perspective, a system may not be considered anonymous unless you are privy to the schema, right?
Of course, but it will still be anonymous to you, the user, because you don't know what is
Yeah, so
behind
by
it.
behind the scene, it could be that they are capturing some data that I'm not aware.
Of course.
Okay, thank you very much.
Of course. How many times have you installed an application on your phone and have gone through the terms and conditions fully before? How many times?
None.
None, I think you just check the checkbox.
The terms and conditions. So one day, just one day, try any of these popular apps that you use. Just uninstall it and reinstall it and try going through the terms and conditions, and you'll see something for yourself. It's just surprising how we
Madam,
are.
that
A
portion we don't
data
care.
policy.
We don't care.
You don't care. You care. You care if you want to do data security, or you want to go into how do we even call it? Cyber security. Um what's it even called? You will care very, very soon. Don't worry. Because I'm sure you would want to know how your data is used, or you don't. Okay, well, some wouldn't care though, but for some of us, we are very interested. So for me, like this, my machine is such that I can close my camera or open it if I want to. There are features on my phone that when I turn on and you take my phone, you can't go anywhere else on unless you are exactly where I want you to be. You get. So there are so many assets they have behind the scenes and we don't see them. But as well, God is helping us all. So
Mm.
yes, we've spoken about the
Madam the hacker.
sub-schema. Hacker. Hey, I'm not a hacker. Oh. And the surprising thing is, although I code, I don't like coding. Although I do programming, I even teach programming, but I don't know why. I don't like coding. But whether you like it or not, some way, somehow, you will still use it, so long as you are studying IT. You may not actually use it, but you will need to understand it to let somebody use it. Like a systems analyst, you have to understand, all these things so that in case somebody's building a system, you are able to tell the person, no, 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 this is not how you go about it. This is how we want it to be like. Yes, so you have to understand it or get to, know it properly. Then we have data repository or what we call the storage. Okay. So this is where all the data is physically stored. So all student record, results, payments are stored on a particular server. Even if you access it from your phone or laptop, the data is still stored somewhere. Okay. That's how it is like. Then, um, what else? All right. And then when we come to the storage of data, we have the centralized versus distributed. Okay, so all data is stored in one place, maybe one main university server. That's when you can access the data altogether. So it's centralized, it's on one main university server. But when it's distributed, the data is stored in what? Multiple locations. And I think that's the best way of storing data actually. So when the Iraq thing happened and Amazon's one of their data centers was bombed and stuff like that, they didn't go down. Their system didn't go down because they had data centers at other, locations. So it just substituted for, the failure that was happening somewhere else, and then things were running smoothly as normal. Okay. Then we have the open database connectivity. So the simple idea behind this is that it allows different applications to what connect to the database. Okay, because it's a connectivity. It's a software. So a mobile app and then a web portal can both access the same database at the same time. Why and how is that possible? It is possible because of the open database connectivity. All right. So when you open your student's portal or a website, where do you think the data is coming from?
It will be coming from a database.
From a database server.
Okay, not bad. So say right now, I ask you, search for Banku and tilapia on Google. Do you think information about Banku and tilapia will pop up?
Yeah,
Yes, I
sure.
think so. I think so.
Yes, I think so. Yes, it will pop up.
It will pop up. Okay. So those things that pops up that you can search through and be like, oh, okay, there's this banquet tilapia at Sunyani. Mm, it's too far from me. I don't like it. They keep scrolling or searching. Oh, okay, there's banquet tilapia near Tesano. Okay, I like this one. What do you think those things are made up of? Those things that keep popping up.
Hello, madam.
Yes, Justice.
Can we say that they are made up of interrelated records or fits?
Yes, we can say that. But I'm looking for a specific word or something rather specific?
Madam, please, can you say the algorithm of it? Like social media,
Sorry.
example, like on social media, if people search for a particular type of video, the number of people searching for it, the algorithm will increase. And so on your timeline, you will
It
just
will come up.
put it there. Yeah. So probably maybe that
Oh,
would.
okay. Oh, okay. That's not bad. Okay. Do we have any other suggestions?
Okay, this Theophilus. I will also say that sometimes it depends on the review and the rating that maybe a person gives you on maybe on Google. We are talking about Google. It depends on the rating that
Yes.
they give you there. That makes maybe your product pops up anytime someone search on Google. Yeah.
I see. Okay.
Hello, madam.
You are
Hello?
all not
Hello?
wrong. Yes, Rogers.
Can we say they are made up of queries?
Sorry.
Queries.
Queries. I see. Okay.
Yeah.
Hello,
All
hello,
right.
madam. Madam. Yes,
Yes,
I
who's
would like to
speaking?
come again. It's the justice. I don't know,
Okay.
maybe if we could also consider it as a metadata, because most of the time Google uses metadata to extract this information from, different sources. So could it
Oh,
be
yeah.
considered
Oh,
as
okay. It's all not bad. I get where we are all coming from. But then this is what I was actually looking for. Whenever you search Google and then something pops up, okay, so for instance, you are searching for Banco and Tilapia. You can try it on your phone right now or your device. Banco. So I'm doing that right now on Safari, but using the browser Safari, but I'm searching for Banco and Tilapia. The moment I hit search, I see a lot of sites bringing up something about what? Banco and Tilapia. These are called websites. That's what I was looking for. So when you open your student's portal, you are opening a website. Do you get what I'm saying? Whatever information you get there is on a particular website. It could be Facebook, but Facebook is facebook.com. It's a website. Although you can have it as an app, but you can also access it, right? So when I searched for Banco and Tilapia, I've seen a couple of sites bringing it up. There's Wattpad that has something on Ghanaian recipes, banku with grilled tilapia. There's Asmera restaurants popping up. There's something from TikTok popping up. There's somebody with UU Kitchen Online. I want you to also try it and see the things that will pop up. All these things coming up on Google that I'm searching through are websites. And where do we think this data is coming from? Okay. It's a web-based design and it's about connecting a database to a website so users can what? View and update data online. Okay. So the databases are created and managed by using languages and commands that have nothing to do with HTML. Just that this HTML or sites that we are seeing currently after searching for Banco and Tilapia is just there for display. So the real data is stored and managed using a database system behind the scenes. So behind the scenes, you can't see when you click on any of the Banco and Tilapia sites that comes up, you can't see how they were able to put the Banco picture inside there. You wouldn't see which parts they or behind the scenes how they were able to. Let me see if I can do this thing and show you what I mean clearly. A moment here. Can you still see my screen?
Yes, madam. You can see.
Yeah.
Let me see. A moment.
Recording in progress.
Okay, so you can't see my screen properly. Let me extend it and see something. Okay. Please, can you see my screen?
Yes, please.
Hello.
Yes,
Okay.
please.
So this is what
Yes.
we are talking about. So I just searched for Banku and tilapia, right? And see all the things that is coming up. They are all showing me or pointing me to one Banku and tilapia or the other. So let me look at Ghana Web. So what I'm saying is that all the all the things or the sites that's popped up showing me or telling me something about Banku and tilapia, they are all websites. Like this one. This is a website. Let's look at another one. Cultureandspices.com. This is also another site. So they are all websites. But behind these websites is a database in which this is stored. So with you and I, all we can see is this, right? But let's look at behind the source and see what we can see. And these are the HTML codes that was used to design this, what we were seeing, these things. This thing that we are seeing right now. The HTML codes that was used to design it is this. Okay. So you'll be doing, I think, web-based design and stuff like that. When it gets there, you learn more about these HTML things. But we are saying that although we are seeing these designs and websites, the main database or the main thing that these things are stored in are the database. These websites are stored within a database. So whenever we type in Banku and tilapia, it goes to the server and then fetches that data from that database and displays it to us in the websites for us to view. Please, do we understand what I'm saying?
Yes,
Yes,
madam.
madam.
Hello.
They're
Okay.
following.
All
Yes,
right.
madam. We got it.
Okay. So let's go back to what we were looking at. Okay. All right. So we are saying that databases are created and managed by using languages and commands that have nothing to do with HTML. So the codes we actually saw are the commands and languages that they used with HTML. The objective is to connect the database to the web and enable data to be viewed and updated. Okay. And then we have something called middleware. So middleware is like a middleman that connects the website to the database. So like I explained, okay, when you log into your student portal to check your results, the moment you enter your student ID and password, whatever comes up is like your browser, right? Sorry, the website of the school. So first you are searching, you request the page or the information for your SIP or student details using your browser, right? So when you enter your browser, Safari, Chrome, whatever browser you are using, and you enter gctu.online/gctu.com whatnot, and it comes up and you enter your student's ID and password. The interface that comes up becomes that website connecting you to your results. Is that okay? Now, the web server was what sent a request to the database to retrieve that website for you to be able to view whatever you are viewing. The work of the middleware is to send the request to the database in order to bring what you are searching for or what you are looking for. Then the database sends back your data, which is displayed to you on the website. Okay. So same thing happens when you check your Momo balance, when you log into your banking app, when you are shopping online. Before something is, retrieved from that database, it goes through what we call the middleware, which is a software. So you don't see it actually, but it's working behind the scenes. So the website is just the interface that shows after you search for something, right? And then the database is the storage. And then the middleware is the the betweener. Okay. Uh-huh. Please, do we understand?
Yes,
Okay.
madam.
So this is just a representation of what we just spoke about, the web server and how the middleware, generates the data query and all of that, and then it's showed to you. All right. So if you have to work properly with data models and structure your data properly, then there are certain terms you have to understand because you meet them everywhere. The first is entity. So an entity is a person, a place, thing, or event for which data is collected and maintained. Okay. So if we want to collect data and maintain the data about GCTU becomes the entity. If we are collecting and maintaining data about SNM becomes what? The entity. So it could be a person, it could be a place, it could be a thing or an event for which data is collected and maintained. Then we have a table or file. The table or file contains a set of related records that stores data about a specific entity. So if the entity is SNM, right? So let me represent SNM by E. and we have a table here. This table will contain what? Everything about SNM. It will contain SNM's name, SNM's contacts, SNM's sex, SNM's complexion, and everything about what SNM. Do we get it? So that's what the table of file has to do. The same thing has to do with GCT. If we take GCTU and we are representing GCTU as an entity, then the table of file will contain what? The number of students in GCT, the number of departments or faculties, the number of lecturers, everything with regards to what GCT will be stored in that specific date table. Then we have what we called field. Now, field is synonymous towards attributes. It's a single characteristic or fact about an entity. A common field is an attribute in more than one entity. Okay, so basically it's telling you more about that entity. Then we have what we call a record or tuple. It's a set of related fields that describes one instance of an entity. We'll be looking at that very soon. So we've looked at what an entity is, right? We said a table is also where the data is kept or stored. Is that not it? Then we looked at a moment. We looked at field or attributes, okay. And then um we said the field or attribute is a single characteristic or fact about an entity, and then a record is a set of related fields. So when we talk about an example for field or an attribute, let's say we have a student table. Okay, so the attributes within that student would also be what? The descriptions. Rogers, your hand is up. Rogers, your hand is up.
Yeah,
Is it a
madam.
mistake? Yes.
No, no, please.
Sorry?
So, madam, in another terms, I have a question.
Oh, okay. Roger, we are listening to
So,
you.
please, in another terms, can we say a field is a column where a record is a row?
A field is what?
It's a column, and then
Yes.
a record is a row.
Of course, when you are okay, before I answer that, what do we think? Yes. Yes, what do we think about Roger's question? Roger is asking whether the field or the attributes we spoke about can be represented as a column. And then the record we also spoke about, can it be represented as what? A row?
Hello, madam.
Yes, Justice.
Yeah, so I think it is true one way or the other, but the field can be rather be represented like a cell or something like that. A cell.
Oh, okay.
So the cell is the intersection of the column and the row.
Interesting. Okay. Do we have any other submissions, please? Any other submissions, please? Is somebody's hand up? Okay. So, Roger, you are not wrong. Okay, so in database, the field or the attribute is actually represented by what? A column. Okay, and then the column defines the type of data. So, for instance, maybe the name, the age, the course. These things are what's placed in a column. Okay, and then the record is also designed in a row. So whenever you are putting all those things together, maybe the students' details and all of that, you do that. Now, when it comes to the intersection between the column and the row, just as when you said cell, it holds a single value. So if you imagine a table, each small box where a row and then a column meets is what? Is a cell.
Yes,
So
please.
this is where the actual data is actually stored in. Okay, but just that within the database structure, wherever the field or attribute is, it's represented on the column. And whenever the record is, it's represented on the row. Is that okay?
Yes, very well.
Alright. Now, key fields are also used to organize, access, and maintain data structures. We have what we call the primary key. And then I think we have foreign key, we have a surrogate key, we have unique key. So with the primary key, it uniquely identifies each record. So for instance, if we are looking at students, the primary key for that student's table will be what? Student ID. If we are looking at courses, the primary key for courses will be what? Course ID. But because we mentioned that within the database, there's a relationship because like there must be some sort of interrelation. That means anytime there's a database about students, chances are we would find courses in that database, but on a different table. Is that okay? We would find lecturers in that database because it has to do with what students or university. I don't know if you get what I'm trying to mean here. We are saying that although we organize databases on structures so that it will be easy for us to access it, organize it, and put it in a structure, they still relate and connect with each other. So if we have a database of a university, chances are you find students' database embedded within that database. You find a database of lectures embedded within it, and you find courses embedded within it. You can't take students and then you can't have some students studying certain courses. Do you get it? So there's some sort of communication or relation here. So for us to identify primary keys within a database, when we take a database for students or a table that identifies an entity, which is students, then that entity we are looking at has a primary key, and that primary key would be what? A student ID. But because students has something to do with courses, when we find a course inside that student table, that course ID becomes a foreign key. Please, do you get what we are saying? So let me quickly depict something here. So this is a student's table, okay? Please manage my drawing for me. And then we have courses table. So this table here is what? Courses. So the primary key for this particular table, which is, hey, I have to start using this thing so that I can use the pen. So the primary key for students will be what? Students ID. So students ID. So this is a table and the field here is what? Students. Please do you get it? Now when it comes to course, the primary key for course will be what? The course ID. But in the event we find course ID here, where student is supposed to be, course ID becomes what? A foreign key. Because originally, this is not where course ID must be, because this table belongs towards students. And the primary key or the thing that uniquely identifies this record is what? Student's ID. Please, do we understand?
Yes, madam.
Yes,
Do we
madam.
have any questions? Or should I go over?
Please go over.
Okay. Please note that this is not a database course. We are just explaining the basic concepts and terms behind it. Okay, so don't stress yourself. Don't be bothered or worried too much. You will understand it when you are being taught database properly. So we are saying that we have certain fields within a database, and some of these fields include the primary key. Okay, we also have surrogate key, we have unique key, we have foreign key, and other keys like that. The definition of these keys are all in your slides and in your textbook. But we want to understand primary and foreign key very well. And so for us to understand what primary key is, we are saying that primary key is what? A field or fields that uniquely and minimally identifies a member of an entity and cannot contain null values. And we are brofo bebre. So for us to break it down, we are saying that, for instance, when you take a student's ID, you can clearly say that, let me see those who spoke today. Sexual affairs student ID is definitely different from Maxam's student ID. You get it? So it is uniquely identifying that person. So when we take a table, and the table is a student's table, so this is our table, students, right? And we are drawing a table. For us to uniquely identify the student's table, we would need something that will uniquely identify that student. What can uniquely identify that student? The student's ID. Please, do we get it? Because that is what is uniquely what identifying that student. And that student's ID becomes the primary key for the table students. Esegoma.
Madam.
Okay. And I also said we have another table called courses here. Reason being that whenever we take a database, there are sets of interrelated connections with it that comes with it. So I started by saying that if we are creating a database for GCT, because it's a university and it has different entities, chances are we would have courses in that database and the various categories of courses every student is studying. We would have lecturers in that database and the various courses they've been assigned to teach. We will have other things also in that database. So when we take course, if you check your course registration form, you would realize that every course has what? A course code. And that's one thing that uniquely identifies that course. So if we take course, we can also say that we have a course what? ID. So when I take your course system analysis right now, there's an ID attached to that what? System analysis that uniquely identifies that course as a level 200 system analysis course. Okay. And when it comes to the table for courses in a database, why we have the course ID becomes our what? Primary key. But in the event, some way, somehow, because a student is offering a course called system analysis, And so course ID finds itself here within the student category, it becomes a foreign key. So it becomes what? A foreign key and not a primary key within students' table. Please, do you understand? So foreign key basically links one table to another. So imagine now it's a student ID that's finding itself here under courses because maybe one student or more are studying a particular course. Student ID here becomes what? A primary key. Although when it was here, it was it becomes a foreign key under courses. Although when it was under student table, it was a primary key. Please, do you get it?
Yes, madam.
Okay. I hope we do.
Okay, madam. So please, for clarity, so the when let's say what is the primary key in another field can become like a foreign key in another field, and that is what relates like those two fields together.
Very good.
Okay, thank you.
Exactement. You're welcome. All right. We also have what we call the super key. We have candidate key. I've already explained foreign key. And we have secondary key as well. Okay, so the super key is anything that uniquely identifies an idea. Okay, so any column or combination of columns that can identify a student uniquely is the super key. So say we have a table, or imagine we have a table, a student table, and we have student ID, we have student's name, student email. So under students, this drawing there, very. So we have student ID, we have student's name. Let me represent it by N. We have student email. Okay. So under ID, we have 1. Then under name, we have, say, Ama. So Ama is represented by A. And then email.com, .ama or something. Charlie, this thing is not working. I'm sorry, guys.
Madam,
I
just go
should
on. We
have brought.
understand. Go by that. We understand.
You understand? Okay. So .com. Let me draw something. Then we have another ID for another student. So that student is Kofi. So we want to draw K here. And then this one is .kofi or something, the email there. Okay. What we are saying about the candidate key is that when it comes to the super, let's start with the super key so that we understand it better. We are saying that a super key is any column or combination of columns that can identify a student uniquely. So in this table, student ID can identify the student clearly, right? Because we know that if Justice's student ID is 2244122, Amma will not have the same student ID. Okay, so it uniquely identifies it. We also have email. It uniquely identifies that student. Okay, so whichever thing that uniquely identifies that student makes it what? A super key. Even if it has an extra information, as long as it points to one student only, it is a super key. Now, for the candidate key, it's a super key with no extra parts. So we remove all the other parts or combinations that make us still see that student. So you can see that within our table here, we have ID represented, name represented, and email represented. We can use any of them at all to find what belongs to who. But with the candidate key, we need only one. And that one thing or one good thing we can use is what? The student's ID. Please, is it clear? For foreign key, we have already explained that it's what? The link between tables. So that one, I'll not go back to it. Then the secondary key is a field used to search, but not unique details. Like it's not very unique. So like we have Ama and Kofi here. We can have departments like IT and HR. So you can search within it, but many people can what? Can share it. So it's not really unique. That's why it's a secondary key. So in case I want to look for Ama or Kofi, I can rather search for their department rather than just looking for Ama. Because there may be many Amas in various departments or there could be a lot of people with what Ama. So it's not very unique like that. But in case I narrow it down on the database and search for all the Amas, it could still come up. Please, do you get it?
Yes, madam.
Hello,
Are
madam.
you? Yes, sir.
Yeah, so like for clarity, for with the candidate key, let's assume
Yeah.
that we have the student's ID, then also
Mhm.
the Ghana card.
Mhm.
Okay, so the Ghana card over here, the field that holds the Ghana card information has become the candidate key. Is that the case? Because that one too
Okay.
can be used to uniquely identify um, the student since it does not
Okay.
repeat.
Okay. So let's assume we are now. Please, who spoke? I didn't get
Justice, please.
justice. Okay. So let's say we are using justice, and then justice is now the field we are studying here, right? So what do you think we can use to identify justice? In case you are entering your details in a database, we
Okay,
can
so
have your name,
my name
right? Yes. We can
and
have your
my student's
age.
ID, age, date of birth,
We can, good. Student's ID, dates of birth, Ghana
my Ghana
card,
card number, SNET
Ghana
number,
card number,
if possible.
SNITs, your bank accounts, which we are very interested in, and other things that can be used to identify justice. That's just by the way, don't mind. Okay. So we are saying that we are saying that the primary key here is that one thing that can identify you as justice. Okay. I mean, the candidate key. So we don't need all these extra, like all these things. So long as we can choose one of them and we can still identify you as justice, that is all we need. That is what the candidate key is all about. So you could have 5 bank accounts. What can we use to identify that those bank accounts belong to you? Maybe your Ghana card. So all we need is your Ghana card or the ID on that Ghana card. That's all we need. Do you get it? But when it comes to GCT, what do we need to identify justice as a student? It's your student's ID, not your Ghana card. Please, do you get the difference?
Yes, I'm getting it.
That means you've not gotten it yet. So what's left?
I am okay. I'm just following.
Oh, okay. So that's what we are talking about. But when it comes to the super key, we can use all of these things with even the things we don't need, including your age, your SNATs, whatever, and all of that. We don't need all of that, but we can also use all of them to still what? Identify it. Is that clear now?
Sure.
Hello, madam.
Okay, so
Hello,
so
madam.
hello.
Yes,
I
yes.
have a question with regards to the illustration you just did.
Okay.
So comparing the primary key and then the super key, okay. In the
Mhm.
scenario you just gave, based on the super key, the explanation means that the super key will give a more or detailed info about justice as compared to the primary key. Would that
Primary
be the
key,
difference?
yes.
Would that be the difference between them?
Yes, that would basically be the difference between them. Notwithstanding that the primary key identifies a specific table
A specific table. Okay.
within your database. So when you check the other slide, the illustration we did connecting courses to students' ID, you would see that students' ID or students was represented by a specific table. And that's how come we had that student ID as the primary thing connecting to courses. Please do you get it? Are
Hello?
we good? Yes.
Hello.
Hello.
Yeah, so please, so can we say the super key is the inverse of the candidate key or the opposite of they are opposite to each other?
Hmm. We can't say they are opposites. Opposites will be far-fetched. Opposites is saying black is black and then there's another color white. They are opposites. But with super key, we are saying that you can use more than one identifier to identify something. Candidate key, you don't need all the other things. You just need one thing to identify that. Do you get it?
Hello, madam. Yes,
Yes.
so I want
Is
to.
primary key a candidate key?
Primary key is not a candidate key. Now, candidate key is an alternate key. So,
Okay.
apart
Okay.
from the primary key, any other alternate key we can use to uniquely identify that thing. That's what the candidate key is about.
Okay.
Hello, madam. Can I also say this? Yeah, let's say that
Yes.
this Theophilus, the super key,
Yes.
let's serve as a passport. We can use passport to travel to, let's say, United States, but we can't use Ghana card to travel to the United States. So the passport serve as let's say the super key, and the candidate key also serve as, let's say, a Ghana card.
Okay. Okay, I understand where you are coming from.
Okay.
I think I get where you're coming from. Okay, let's move on. So, please, this table here is describing what we've just looked at. So please check that on your reading material. I think it's more clearer there because I don't know why it's not clear here. Let me see, where is it? Yeah, all right. So this is how a database looks like. And then we are looking at referential integrity. And then, okay, so in a relational database, referential integrity means that a foreign key value cannot be entered in one table unless it matches an existing primary key in another table. Okay, that's what referential integrity means. So referential integrity is a set of rules that avoids data inconsistency and quality problems. This is an example of Microsoft Access. So this table is a mechanic table, and this table here is a job table. Let me see. So, oh, okay. So within the mechanic, so this is a mechanic field, and this is or entity, and this is a job as an entity. Within it, we have the mechanic number, name, pay rate, hire date, status, insurance, and all of that. Okay. And then when it comes to the job, we have job number, work code, da 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 da. So within the mechanic table, which one do you think will be the primary key?
Hello, madam.
Yes.
I think the mechanic number is the primary key over here.
Okay. How about when it comes to the job table?
Yeah, it's the foreign key because it is
It's the
requesting
phone.
for. Yes, please.
Okay. So that's what how do we call it? Referential integrity is. So unless there's a database or there's a table that has details of a particular entity, you cannot connect it to another table so that there will be no inconsistency. Okay.
So,
So for
madam,
example, yes.
so can you say that with the referential integrity, it has to do with one-to-one relationship,
No, not
maybe
really.
one-to-one
No.
mapping or something like that? Because
Something like that.
can it be
I
considered
I
like
get
that?
I get you, but not necessarily. Not necessarily. Okay.
Okay.
Because the referential would prevent you from entering. Let's say we want to let's represent this by a customer placing an order. Okay. So if a customer places an order in table one, and then the customer exists, like the customer already exists in table one. So you cannot enter a job for a customer that does not exist in table one. That's what we are representing here with the referential integrity. So we have a mechanic table. Mechanic number exists within the mechanic table. If it does not exist in mechanic table, it has no business being in job table as a foreign key. That's the business of the referential integrity. Please, do you get it?
Yes, please.
Uh-huh. So in case there's nothing about mechanic in this database and you want to enter mechanic number within job, it will reject it. That's how the database is designed to, to operate. But we'll get to where you are talking about the one-to-one and the one-to-many. That's the entity relationship diagram. So the entity relationship diagram is a visual tool used in database design to represent the relationships between different data entities in a system. Okay, so entity is anything real or identifiable that we store within the database. So, for example, student is an entity. Lecturer, we've already spoken about that. The attributes are the properties or characteristics of that entity. It could be the student ID, student's name, email, department, da da da. Relationships are associations between what? The entity. So the connection between the things. Example, if a student enrolls in a course, there's a connection between what students and then course. If mechanic works on a job, there's a connection between the mechanic and then the job. So within every entity relationship diagram, which is the ERD, we have entities, attributes, and then relationships. So this is an example of this entity relationship diagram that has been related here. So to draw an ERD, the first step is to list the entities that were identified whilst you were doing your system analysis. Okay. So when you were doing your system analysis phase within your project, you would note the entities or people or things that are being focused on. Then from there, you deduce their descriptions or attributes. Okay, so this is a popular method of representing the entities in a rectangular shape. So in this case, we have doctor as an entity. Now, the entity rectangles are labeled with singular nouns, and then the relationship between them are labeled as what? Are drawn as diamonds, this diamond shape. When I was growing up, I used to call it as triangle up and down. That's just by the way. So that's it. So these rectangles name the entities, and then the diamond shape represents the relationship, okay, and then they are labeled, as with verbs or something like that. So in an ERD, entities are labeled with singular nouns and relationships are labeled with verbs. The relationship is interpreted as a simple English sentence. A popular method is representing entities as rectangles and relationships as diamond shapes. Anyway, that's just by that. So we have different relationships when it comes to database. So what you said, we have the one-to-one relationship, we have one-to-many, we have many-to-many, and all of that. Okay. So in this case, we are looking at one-to-one. The one-to-one relationship means one record in entity, and then that one record in, let's say, entity A is linked to only one record in entity B and vice versa. So when you look at this diagram very well, in this ERD, office manager we have just one office manager, right? Each office manager has what? Only one head. Okay. Excuse me. Each office manager heads only one office, and each office has only one what? Office manager. So that's the one-to-one relationship. When you look at the vehicle too, each vehicle has only one what? Vehicle ID number, and each vehicle ID belongs to only one vehicle. Okay. So a Toyota Corolla has its own unique registration number, its own unique chassis number, and that number cannot belong to another car. The same way, each person have their own social security number or SNIT number. Okay, and each social security number belongs to only one person. Please, do we get it? That's how the one-to-one relationship works. Like, then we have one-to-many relationship. So one record in entity A can be linked to many records in entity B, but each record in entity B belongs to only one record in entity A. Please pay attention. So a one-to-many relationship exists when the occurrence of the first entity can relate to many instances of the second entity. But each record in entity B or the second entity belongs to only one record in entity A. So for example, one parent can have what? Many children. But each child can have only one parent in that relationship. Please, do you get it? So we have one department, but that one department can have what? Many employees. But each of those employees can have one department. One student can have one department or faculty. You can't be in GCTU and you're in the faculty of computing and you're at the same time in the faculty of engineering and business at the same time. Please, do you get the idea? That's how the one-to-many relationship works like. Then we have what we call cardinality. So when you are drawing the database, this is how you represent them. Think of cardinality as answering the question, how many of X can relate to how many of Y? How many of X can relate to how many of Y? For example, how many students can enroll in a course? How many courses can a student take? So the symbols on the left side of the line tell you the minimum and maximum number of times an entity can appear in a relationship, okay? So it could be exactly one, which is no more, no less. It's just exactly one. So if you are representing this data in a database, this is how you draw it in case you are drawing it. So that will be how the cardinality is, is mapped. Then one or many. So that means at least one. It could be more, but at least there must be one. Okay. Then 0 or 1 or many. So it could be none, 1 or many. And then 0 or 1. It could be optional, but never more than 1. So this just explains how they are represented in a database. Okay. So can we give an example of one and only one? For instance, a student has one and only one ID. Can we have any other example?
Okay.
Email.
Emmanuel, who is talking?
A student having one and only one email.
One and only one email. Okay.
Okay, madam.
Yes, any other?
The course code for each course, like it's 1-to-1.
One and only one course
Sorry, one and
code
only
to
one.
a
Yeah.
course. Okay. How about one or many? One or many. A lecturer could teach one or many courses. Do we have any other examples? One
Hello,
or
madam.
many?
Hello, madam.
Yes.
Yeah,
Yes,
so
sir.
students can enroll one or many courses.
That's good. Any other? Any other? So at least we have the idea or we understand what it means.
Okay,
Okay,
madam.
then, yes.
Hello.
Please, what about
Yes, I'm listening.
a case where like the student's name has been separated to first name and surnames? So can we say the student will be related to one or more than one name?
Okay, I understand you. That's okay. All right. So let's move on to this particular diagram here.
Hello,
When you
madam.
look at this diagram here, yes, who is
Yes,
talking?
please. I want it's justice. I want to
Okay.
ask, yes, with regards to the relationship,
Yes.
like I I think some time ago I came across many to many relationship. Many
We'll
to
get
many.
there, don't worry.
Okay. It wasn't mentioned, so I
Mm.
wanted to find out if it is not part of
Find
them.
out. Oh,
Yes.
yes, we have many to many. We have a lot of them. But that's why at the beginning of this one, today we are looking at data AU. But then we just want to understand the basics of all these things as system analysts. So when you are being taught databases itself, they'll go beyond what we are doing right now. Please, do you get it?
Yes, madam.
Okay. So let's look at this image here. What are the entities in this image? What would you say the entities are? I'm sure we've spoken about entities severally, so we understand what entities are. So can we point out the entities in this?
Yes, hello, madam.
Yes.
I think users, book, and authors.
Justice, you have said it all.
User.
Users.
Sorry,
Let me put it that way. Users.
users. Oh, okay. Do you have any other? Do you have any other entity?
This one, Justice has said it all. So you don't know which one to
Really?
give you.
Are you sure he said it all? What are
I,
entities?
I did earlier, but I think I will do that when I said it for the second time.
I don't think it's all done. There are other entities here.
Add new book.
Add new book. Yes.
Checklist and checkout list.
They are all entities. Or because the user book and ATA has been has been like the color is different from those ones. So they are all entities. So what do you think is the relationship going on here? From what we've learned with regards to one and many, the symbols we just use. So this is a crow foot. That's how it is called. A crow foot with one bar on it. Then we have a crow foot with 0 or something on it. So with these cardinalities that we have here, what can you say is the relationship of this? So you can take just one and then you tell us the relationship.
Hello, madam.
Yes.
Yeah, so taking the user entity
Justice, you've spoken a lot, Pam. Let me dash you 5 marks.
Thank you, madam.
Stop clearing your throat, my friend. Today I heard from Setrafia. Carstens, today is the first time I've ever heard you talk. And that was a prayerfully powerful prayer.
Yes, madam. I'm always available.
Naya, Emmanuel Baja, Rafik, Angelina, Theophilus, Roger. You are the only ones. You think when you are speaking, I don't record it. Every day I give marks for those who at least spoke or did something. Also, answer your hand is up. Justice, hold your thought in.
Hello,
Sure,
madam.
madam.
Yes, also answer.
Could you go back to the previous diagram, please?
Okay.
So the 0 or 1 or many. Could you give an example? Because I seem lost over there. I'm trying to get it.
Okay. So maybe a student may have 0 or many library books borrowed. So we have a library at GCT. Chances are you've not even stepped there before. Or you went there, you borrowed 1 book. Or you went there and you borrowed more than 1 book. So that's a tangible example to that.
Oh, okay, thank you.
Yeah, well, I should have asked the class simple. Anyways, yes, back to you, Justice.
Okay, so madam, I was talking about the user entity. From the user entity to what is borrow book during, borrow book during to the book checkout. I'm talking about that particular one. Right. So from the user is 1 to 1. The diagram over there shows 1 to 1. And to the checkout book, it is 1 to many. So basically what is going on is 1 to many relationship.
Sure. So a user borrows 1 or many books.
Yes,
at
please.
check and then book checkouts. Okay, I get it. And then from book checkouts, one user can have multiple or borrow. Okay, all right, that's fine. Yes, any other? Or I should give it to you as assignments. It's been a while I gave you guys assignments.
No, please. We will solve it. We'll do it
Please,
here.
you will
We'll do it here.
Time is also fast spent. It's already
We'll finish it
3:20.
here, please.
So you can go through it and then we'll see. All right. Please, can somebody read for us? Somebody apart besides Justice.
Hello, madam.
Yes.
Okay. Data normalization. Data normalization involves structuring a database so that each table represents a single concept or entity and relationships are clear.
Okay.
Can I go
So
on, please?
think of normalization like organizing a messy cabinet. Okay. If you dump everything into one drawer, it becomes very hard to find. Okay. So normalization is the process of organizing your database tables so that each table talks about one thing only. So if we have students table, it's only storing information about students, not course, not lectures, not, any other things. Okay. So that the relationships between the tables are clear and logical. Please continue.
A table design specifies the fields and identifies the primary key in a particular table or file.
Okay. Continue, please.
Normalization typically involves the following stages. 1. Unnormalized design. 2. First normal form. 3. Second normal form. 4. Third normal form.
Okay. So for the normalization, think of it like as levels of tidiness, where each level is stricter than the first. So when it's unnormalized, I first represented it by how do we put it? Giving an example of having a messy room. Okay. So unnormalized means it's still in that messy state. First normalized means you have started picking everything from the floor. Probably it's all over the floor and all that. Second normalized form means, or second normal form means, now the things that were scattered and all over the place, you have picked them and you are putting each one in the right box. Okay. Third normal form means everything in that room has now been put in its place and the room has been swept and well kept. The same applies with the columns and the tables we have. So if a table is messy and full of things that are not supposed to be in, first normal form means you've identified those things that are not supposed to be there. Second normal form is you are putting those that are supposed to be in specific rows and columns in their positions or their proper places. And then the third normal form is then you are able to create a link to, communicate with each table properly so that those um, messy table things will no longer be existing in that database. So basically, that's the idea behind normalization. And I think that's what has been explained here. Okay. So let's move on to codes. A code is a short symbol or abbreviation used to represent a longer piece of data. So you already use codes every day, even without thinking of it. For example, what's the code for Ghana? Hello, are we here?
GH.
Good. So that's what a code. So these codes are shorter than the data they represent. They save storage space and cost, decrease data entry time and transmission time, reveal or conceal information, reduce data input errors, and they are what? Easier to remember. So when you're creating a database, for the most part, database designers don't want to put the full entry things in there so that it will be a bit easier to, manage. Okay. And then codes make data efficient for the computer. So it is for the computer's understanding for the most part. Okay, rather than the user. That's why we use the codes. Now we have different types of codes. We have sequence code, we have block sequence codes, we have alphabetic codes, we have category codes, and then abbreviation codes. So the sequence codes, obviously, with the way the name is, you should know that they are numbers or letters assigned in order. So they are one after the other. So if a student's ID is 001, the next person will be 002 in that order, right? Then the block sequence codes, they are similar to sequence codes, but groups of numbers are reserved for different categories, okay? So for level 100, their numbers may be from 100 to 199. Level 200, from 200 to 299. That's the block sequence codes. Then the alphabetic codes, that's the codes that uses letters to, distinguish items, okay? Then the category codes identifies what? A whole group of related items under one code. So like when you go to the supermarket and you are looking for dairy, you know that dairy things would include group of milk, cheese, butter, and all of that. They are all under dairy. Okay. When you look for children, you are looking for toys and everything that has to do with children in that, those are the category code. Then we have abbreviation codes. For example, Ghana, GH, mathematics, MATH, all those things. Okay. All right. Then the following are several types of codes. We also have significant digit codes, where each part of the code actually means something, like a product code. Okay. So in case you go and then buy something, especially those who import things a lot, you can have something like 2-30-15, where 2 means warehouse 2, 30 means on shelf 30, and then 15 means the item number. So for those who import things a lot, you'll be able to understand the significant digit codes better. Then we have derivation codes. It's built by pulling information from different characteristics of the item and combining them. A typical example is the car codes. Okay, so for example, if you find something like Toyota-Red-2024-SUV, it's basically telling you the brand, the color, the year, and the type of car. So these types are what derivation codes. And cipher codes are what we call the disguised codes, especially when it comes to how do we call it? Cyber security. Okay, these disguised codes are kind of classic in that they can assign letters or digits and then assign numbers to the letters and digits. I'm sure you are going to learn that when you get to either data security or internet security or computer security, one of them. We call them Caesar cipher. The person who brought it about is called Caesar. So this cipher, for example, I want to send a message to Justice, okay? And I don't want any other person to understand what I have said. I would assign specific numbers to certain alphabets. So maybe A, B, C, D would be assigned with maybe A would be 5, B will be 6, C will be 7, D will be 8, E will be 9, G will be 8, F will be 10, G will be 11. So if I want to say, what can I say with A, B to G? Okay, if I want to say bed, which is BED, because I've assigned certain numbers to the letters, I don't have to write BED. I'll rather write 6, 8, 698, because I have represented A with 5, B with 6, C with 7, D with 8, E with 9, F with 10, G with 8. So do you get it? That's how Caesar cipher works. Okay. So you may not know the keyword or exactly what I am saying, especially when I'm concealing an information. Also answer, your hand is up.
Yes, madam. So I was Sorry, I'm asking, is it same as a military form of communication during war? And yeah, I mean, when they want to communicate to each other.
So when I was studying about it, that was the history. It didn't really specifically tell us that's the exact way they communicate, but that was the idea behind coming up with the Caesar cipher. So if, for instance, let me give this example. The way the Iranians and then the Israel this thing went about, that would mean that the Iraq people would have a different set of Caesar cipher. They are the only ones who will know which numbers has been assigned to which alphabets. So when they are sending a message across, they are the only ones who understand it. And if we are using Israel too, they also have unique numbers for each letters. So they are the only ones who will understand it. That was how the Caesar cipher things came about. But as to whether they are still using it, I can't tell. And we can't also tell the exact Caesar cipher thing they were using. But you can read around that and come and share with us maybe some other time. And then we have the action codes. So these don't just describe data, they trigger something to happen. Like the del code. The del code in your machine, your your laptop or computer. What does the DEL code do? What does it do?
It deletes.
It deletes. Okay, so those are action codes. They trigger certain actions. So when you're designing a code, you have to be. Our time is up, and please, spare me 5 minutes more. I beg you. So if you are designing a code, you have to make sure it is intuitive and then meaningful. A good code should give you a hint about what it represents, okay? So if I'm looking at GHSTU 001, I should be able to, know that this is what Ghana students and their IDs, 001. Okay. It has to be consistent. Sorry, it has to be consistent structure. Okay, all codes must have the same, it should follow the same pattern, so that if you are writing that in the database, now note that this codes you are talking about has nothing to do with cybersecurity or security. It has to do with what you are representing in a database. So it should be something that you yourself you will not forget, although it is unique and all of that. It shouldn't be something that you wouldn't know. Okay, so I used this quotes for, or this del for delete. Then all of a sudden you're using DEL for improve or add again. It wouldn't make sense. Okay. It should be simple and brief. It should be consistent and follow, certain rules and formats. If we are using caps, it should be all caps. If you are using caps and this, it should be like that. Like there should be some sort of consistency. Then it shouldn't be ambiguous. For instance, we don't know whether you're writing 0 or O. Okay, so it shouldn't be ambiguous. And then code should avoid ambiguous characters in code. That's what I've said. Design code so that they detect errors and be sorted and grouped. Okay. A well-designed code should make it obvious when something has gone wrong. For example, using a check digit that flags invalid codes. So codes should also be designed so that the system can sort them in a logical order, basically. All right. Now, tools and techniques when it comes to database, we have a data warehouse. Okay, think of it as a company's central library. It pulls together data from every corner of the organization, including sales, HR, finance, operations, and all of these data are placed in one place. Okay, the data might seem unrelated at first, but having it all together allows management to see, the big picture and the spot patterns they wouldn't have seen if they were scattered across Okay, so that's what data warehouse is all about. Then we have the data mart. A data mart is like a smaller specialized section of a library built for one specific department. So the finance team does not need customer social media data in there. Okay, the sales team does not need payroll records in there. So a data mart gives each department specific things they need, the things they only need, making it faster and simple for them. That's what a data mart is also about. All right, so these are the features of a data listing. I think this semester I'll be teaching data mining and data warehousing. I don't know if you people would be part of it, but if you are, I would go into that more. Data mining involves looking for meaningful data patterns and relationships that can help companies make informed decisions. So it's effectively mining and analyzing data can offer the following: customer segmentation, you can make predictive analytics, marker basket analysis. We have something called customer lifetime value prediction, sentiment analysis, and churn analysis. We have optimization and marketing campaigns. So this is where databases stop just storing data and start generating insights. So think of data mining like gold mining. You dig through huge amounts of raw rock, which is the data, okay, looking for valuable nuggets, valuable gold, species, and piece of this gold. You're looking for patterns and relationships. And all these things help the company make smarter decisions. That's what data mining is all about. So if you sell, or if you're working for an organization that is into telco, maybe MTN, the telcos like this, MTN, precisely. And then you see that, okay, after conducting our mining and everything and analyzing our data, we realize that people between 70 and 100 don't use mobile money. Then now, based on that, you can make a predictive analytics and then make decisions to help your company progress. That's what data mining is all about. Now, when it comes to database, we have logical and physical storage. Logical refers to data that a user can view, understand, and access regardless of how or where that data is organized or stored. And then physical storage is strictly hardware related. So for those of you who will be doing data analysis, you can use logical storage, okay, so that you can be able to, a user can view it and understand and access it after you've even run your predictions and all of that. Okay. Now, the last thing I want us to look at before we leave is data control. Now, a well-designed database management must provide built-in control and security. It's not just about a storage box. It must have active defenses. Okay. And most of these database softwares have built-in features to ensure that data remains consistent, accurate, and protected from both external hackers and internal mistakes. So they must have layers of protections, they must have access limitation, identification, and all of that. You have to grant permissions and even encryptions to be able to do that. And there must be backups and recovery. Because security isn't just about stopping bad guys, it's also about preparing for bad luck. Like in case there's power outage or hardware failure, what can we do next? How do we get our things to work and all of that? Then we have backup retention. Okay, you must keep copies of the database for a specific amount of time. We also have recovery procedures, specific steps you have to use to restore the data from those backup copies without making mistakes and errors here and there. Okay. So I think basically that's all for today. Any questions, please? Any questions? Hey, because I've used 10 minutes of your time, so nobody will ask any question. Okay, since we don't have any questions, I have a question. And the person who answers that question also gets 5 marks before we leave. Now, when you go to a mobile money vendor to do cash out and whatever, why should the vendor see your name but not your full transaction history?
No, madam.
Yes, Edward.
Okay. It's because of the number. Your name is assigned to the number. So once you use the number, your name will come and it will identify who the real the number is for.
Okay. Angelina.
Hello.
Angelina, your hand is up.
Yes, madam.
Yes.
I think the number has a primary ID, and every number is unique. So once it's unique, your name is assigned to it. But for the sake of data protection as well, they can't show you. The agent is not supposed to see the customer's money in his or her account. They can only confirm the name to know that that is the person he or she is assisting for the cash out or cashing.
Interesting. Okay. I want us to think like database engineers right now because we just finished it and I'm still on the same page. Benjamin Atta, your hand is up. I'm not saying what you're saying is wrong. All you're saying is true, but I need something specific. Benjamin Atta, your hand is up.
I think my submission would have been the same as what Angela said, to prevent the person from getting more information about the person doing the cash out.
Richard Primpon, your hand is up.
So during coding of the application, that user, everybody has his user account. So that is what he's privy to. So that it has been coded in such a way that that's what he can see. The rest of the things that he can see, that belongs to
Richard, what term can you give what you are saying right now? What term can you give it?
when I say the back end.
Okay, I'll give you one.
Okay.
Justice Ahin, your hand is up.
Hello, madam.
Yes.
Yes, please, can you hear me?
Yes, I can
Yes,
hear
well,
you.
I would say that mostly they do that to protect the user privacy and enhance security compliance. In security, normally we use what we call the AAA, the authentication, authorization, and accountability. So you
You've
need to
gone
be
too far. You've gone too far. Rogers, yes.
Hello? Hello?
Rogers, yes.
Yes, I think it's because of data
Yes.
protection and also because of data structure, how they structure the data. So they protect some parts for end users not to view it.
Okay, last try. Richard, your hand is up again, so this is your last chance.
Hello, madam.
Yes.
Yeah, so I
Yes, I'm
think
listening.
maybe to minimize fraud risk. To minimize fraud risks.
All you are saying is true, but we are actually staring at the answer in our face. Senor, you are the last person.
Oh,
Madam, so
okay.
please, I think you spoke about that during the permission and encryption. So that's the data.
Madam, your line is breaking now. We can't hear you.
Hello, madam, please, we can't hear you.
We can't hear you.
No.
Madam, check your connection.
Hello. Now.
No, madam.
Hello, can you hear me?
Yes, madam, it's clear now.
Yes, we can.
Oh, okay. I'm sorry. I think it was my connection.